Just did that. So why?
6, but I'd really like you to do 8. You know, just to make it easier on me grading. But I also want to feel like you guys did a little bit more than the minimum.
Wait,
the ones I grade.
You actually just did 6.
No, I did 14.
So, no, but I was pretty happy. So don't don't.
Well, you were the one. You weren't here, so we didn't know what you were doing.
Yeah, that's you
I
were
was
the
the one
problem.
who was the oh yeah, thanks.
We all agreed on
No.
doing 6 until
Yeah,
we
right,
found out
whatever.
you weren't gonna be. What? He told us you're not going to be here, and so we don't know what she's going to do. So we're all like, I guess we have to. Do
No, that's
right.
like, okay. So I was pretty glad. I mean, once I graded, I was pretty happy, right?
14.
See?
So okay, so no, I was pretty happy the way
No
you guys
offense,
did, So I would have actually been very sad if all of you did only 6, because that sounds so wrong.
No, the option is between 6 and 14. You're gonna get close to 14 as possible. If
No,
not, it's not odd enough.
I'm saying people did try 14, and most of you got most of it right?
Or what you could do is you could.
Anyway, so I'm not going to get it the way.
No, I'm just saying you could do you could say do all 14, but mark 6 or 8 that I'm gonna really grade, and the rest are just completion grades.
Anyway, but I think the final exam would be like I give you and ask you to write those, probably not the choice. I just want to try how about the choices, but actually it made me feel good because you actually all tried 14. So that brings us to the course project, right? It's actually due on Thursday. So
You mean the proposal?
yes. So how is it going? So why don't you go around and tell me what your project would be, what area? You have to know by now, right? So because it's only 2 days, right? So you want to start?
We were just thinking about using a forwarder node and moving it to the kernel level instead of having it at the application level.
For media streaming.
Yeah, for the media streaming.
Okay, so I want like a very high level saying media streaming, wireless, whatever, right?
Steganography and
A little bit more.
no, sorry, I'm thinking. There's just this one method where you have to embed the data in 4 frames, and so we're going to look at embedding data into a movie and how encoding would affect the data, and if you could still, I hypothesized that you could still retrieve all your data, that your encoding would be a big deal.
Is it like an MPEG 4?
Yeah.
Okay.
Yeah.
Okay. And you guys?
I was interested in doing something with the peer-to-peer thing that you mentioned, file sharing, like HTTP. Wasn't sure who, board with.
We haven't narrowed it down to a single one yet, so.
I'm sorry?
We didn't pick one out yet, really.
Oh, okay. Yeah, if you don't have an idea, drop by or whatever, right? The other thing I would say is, I want to do it by Thursday, so people would use the fall break wisely. But if you have to, I'm open to extensions for that, because the idea is that's not the final thing, right? The idea is I want sense that you guys are thinking. So if you come back and say I haven't thought about it, then there's no extension. But if you say I've thought about it, but whatever, right? So what do you?
Well, what we want to do is take a frame and kind of in a way interlace it on purpose. Only we want to make 4 subsampled images, and then we want to compress them all separately using H.264 and code them all separately, so that you can stream them all separately without error correction data. So that if one of the streams were to get lost or corrupted, due to storage issues or bandwidth or whatever, you could still approximate that missing stream and get a good result. Kind of the logic behind this is when we did our streaming project, and things would get lost, all of a sudden you would get really big noticeable errors, right? Meaning you don't have a graceful quality degradation as data is lost. So the idea is using this method, we can have a graceful data degradation. The question that we want to examine is how is size going to change of the 4 smaller streams as opposed to the 1 larger one, and how is quality going to be affected? And it's going to depend upon the actual data that you send.
Did you say you're resampling the image? Or you're making subsamples?
Yes, we're making subsamples.
So my sense is like people would argue that MPEG-4 would degrade gracefully, right? But it maybe it's not true because like the paper, the one of the that we'll read on November 19th would go through and look at the stuff, right? So even the case that the dome case I mentioned, right? The assumption is looking at the dome all the time should give you excellent compression, right? Because there's no motion. I mean, you should only send I frame and send nothing at all at the P frames, right? But I'm not really sure that that's actually true, right?
Yeah.
Depending on, because like, things change slowly. So if you start from the morning till evening, then things change so slowly that you'll just either miss the whole thing, right?
Yeah.
You probably won't have the problem if you have I frame every so often, because then you're essentially resetting yourself every so often. But the conventional wisdom that in this case you don't have to send too many stuff, I think is not quite accurate. If I think seriously about it, it seems like it's actually the worst case, right? Because you have to send all these frames. So actually that's the worst case, not the best case, right? So there are issues about what people think, and if you think deeply, things change, right? So good. So I look forward to seeing the stuff. And
Just watch out for the high frequency noise.
Yeah, those aren't going to work well under RC.
Huh?
The higher frequency noise.
Oh, from the subsample? Well, I mean, just low pass.
I think they're trying to subsample spatially, right?
Yeah, we're doing spatial subsample.
Yeah, I know, when you spatially subsample an image, you increase you add high frequency noise, yeah.
So, how many of you actually read the paper? The answer has to be everybody, right? Because so at least for the papers, I want you to read the paper before you come to class, and hopefully the papers are not too technical to follow. Especially this paper was a survey paper back in the days, but. So for people, I don't know, like I guess for graduate students, you should be aware of like how to read papers. For the undergrads, if you haven't done reading papers and stuff, one of the things that you want to look at is you want to read the abstract and see what the paper is talking about. You want to read the intro, right, and the conclusions, and then start going from there on in, right? So if you don't understand the abstract and the intro, then there's something seriously wrong with the paper. And hopefully we don't have any of those papers in the class, right? If you don't understand the details on results, section 4 on like some massive experiments that they're doing, that's perfectly fine. I mean, those are targeted for people who are working in the field and stuff, but you ought to be able to understand the intro to get a sense of what we're going to talk about, right? And I tried to have as many survey papers as possible, and this is one of the survey papers, kind of giving a broad overview of some of the, they're talking about how you should build storage systems for multimedia, what are the challenges, and what are the things that you should worry about, right? And one of the authors is the author of the OS book that we at least use for the undergrad OS, right? It was published in 1997. So for people who read the paper, right, what do you think of the paper? How did it sound? Did it sound brand new, topical, or did it sound like some from ancient times? It does sound like it's from ancient times, right? That's the weird thing about this field. I mean, you look at the paper and you go like, but that's so old, right? But it's not old. I mean, this was done less than 10 years back, right? So we'll see what they said, and I'll try to kind of place it in context of where we would be. So I think whatever they said talking about media server in the context that they talked about, this paper is too old, right? In terms of media server, in terms of what YouTube say would do for all the consumers and stuff, YouTube would be facing a totally different set of problems than what this paper was talking about. YouTube would be doing stuff that sort of what the paper will read on Thursday, right? The paper we read on Thursday is on HP, internally doing stuff on media servers and stuff. So they'll be talking more about the media servers which are currently used, right? So in that context, what they call as servers, ignore what they talk about. What they call as servers is probably what you'll see in your home in terms of a TO or whatever. So whatever this topic is still appropriate, not in the context of a server, but in the context of a personal device. And towards the end, I'll give you some hints on what these things would be, right? If you want to jump ahead, the player that Microsoft announced, how many of you followed the Microsoft Zune, the new stuff, right? So what do you think?
I don't think it's going to go anywhere. It's basically an iPod. It has Wi-Fi on it, which is going to cost them more to build than the iPod.
Okay, forget about the commercial part of it, the technical part of it.
It's a nice device.
Yeah, yes.
I don't know. When I read specs, it just seemed like I was looking at another iPod with Wi-Fi. Just so you don't see why, because usually media is pretty heavy, and Wi-Fiing it won't be that much faster than just hooking up to your computer.
So did you figure out what exactly the Wi-Fi is supposed to do?
It's gonna let you, like, let's say you're like a group of friends in the middle of nowhere.
Like here.
Yeah, and like I want to give him a song from my player. I can send it to him over without having to like plug his device into my computer or whatever. But the thing that's gonna cripple it is it adds a DRM to it.
You forget about the DRM part, right? So yeah, I know.
But he can only play for like 3 times once you do that.
In 3 days, right?
Oh, no, I think it's play 3 plays maybe.
No, I think it's 3 times in 3 days.
Oh.
And then it becomes useless, right? So ignore that part, right? Ignore the part that about 3 times 3 days, right?
Yeah.
But I think you can also only give it to 3 people. I think there's a 333 here, right?
Okay.
Right?
What's the point?
So let's not worry about the marketing part of it, right? But the aspect that you can give it to 3 people at the same time, right? So your device can stream to 3 different people and still be playing. I mean, so it has to be enough to play, serve to 3 different people and serve, right? That is the server that device would have to face all the things that you're talking about here, right? Your Zune is likely not to be a SCSI disk that you're walking around with, right? So for that device, for the network that it has, 3 users, it will face all the things we're talking about here, right?
Are you able to play while you're sending?
I don't know. I mean, I don't know we haven't seen the drive, right? But I would assume that when you're sending it, the device doesn't kind of not do anything, right? I mean, if I were to build this device, I would expect it to play while serving 3 different people, right? I have no idea what they've done.
I think it just sends a copy. It doesn't stream it.
So whatever. I'm saying, so it has to have good quality of service to you and to these people, right? So it has a very small disk, and it is not going to be powerful enough. I mean, the network is not powerful enough. The disk is not powerful enough. It's not going to have enough buffering. So all the things that you see here should be applicable to that one, right? I would think it will be resource constrained enough that it may not be able to do this 3 or 4 people, right? So so I think this is applicable more in that context, right? And that's not a bad thing, because if at all Zone takes over, then you're going to have enough people to worry about. So
It has a bigger screen too. But
What?
it's a different issue. The Zune has like a 3.5 inch screen versus the
2.8.
2.8.
Yes, diagonally it's bigger, but the number of pixels is the same. So yeah, the pixels are, I mean, one is 2.8 diagonal, the other is 3.0 diagonal. So yes, it's 0.2 inches diagonally bigger, and I think Zune is, you look at it this way, an iPod you look at it this way. So yeah, but from a technical perspective, it's still the same number of pixels you have to drive, right? So the DRM and all makes it all weird, but from a technical perspective, this is a device that would have to solve these kind of issues. So the paper talks about where this can be useful, in terms of digital libraries and archival processing and so on and so forth, right? And I think they also talk about a VCR kind of device, because I think at that time they didn't have this concept of a TiVo, right? So they're talking about this abstract device. So I think what is more appropriate for us right now is like stuff like Zune or one of these devices. In terms of Media Center PCs, right? How many of you have Media Center edition of Windows XP? Right. So the idea here is, your PC ought to be able to record TV programs, play TV programs, and stuff like that, right? So even though you don't call it real-time systems, you would like it to be, when it's recording a program, play your contents in a nice fashion, right? And TiVo-like devices, I'll probably get back to it a little later too. How many of you use TiVos on a regular basis?
I don't have a TV.
Right? Okay. So one of the things that TiVo-like devices let you do is, record it as you play, right? And be able to play it back, pass and forward and all those things, right? So let's ignore the UI part of it, right? Essentially, it lets you record the live program and play it at a different rate. So there's a recording component and there's a playback component, right? And they're playing with the same hard disk, right? And more, these TiVo devices have more than one tuner. Right? For example, the one I have in my home is a satellite device, right? Has 2 satellite tuners and 1 over-the-air tuner. So it essentially has 3 tuners that it can store, right? So 1 it can take from your broadcast, over the air, and 2 from the satellite, right? And the 2 can be in high definition, right? And the over-the-air can be in high definition. So it can essentially record 3 high-definition programs at the same time, right? And it can play them out through 2 different TV output, right? So essentially, it can be recording 3 things at the same time and playing out to 2 different users at the same time. One of them is high definition, the other one is not high definition. But from the disk, it's still coming as high definition. So it can actually be recording 3 different things and playing 2 different recorder components at the same time, right? And it's not exactly a high-end system. I mean, this is the not the low end, but like the normal kind of stuff. So if you look at it, that as a device, right? It's doing 3 different things out of 1 hard disk, because that's all they put in there. So it has to be doing something. It has to be facing all the things that this paper will talk about, right? So if you ignore the part that is no longer a server, the things that they looked at are still valid, right? The paper talks about MPEG-1 and MPEG-2, and you kind of have to say, that's too old. I mean, we're not going to deal with MPEG-1 and MPEG-2, even though some of these players still do MPEG-2, right? You ought to be doing MPEG-4, because there's no reason why you won't use MPEG-4, because MPEG-4 gives you much better compression than MPEG-2 for the same stream, because it's more aggressive, right? And one of the important things that I want you to think about these devices is the research back then was all trying to be able to predict, trying to say how much they can tolerate, how much they can. So if you have more users than they can tolerate, you have to have some kind of admission control which says how much, whether it can kick you off, right? That means you need to have facility to predict how much resources you need. So if you read the paper, it has some summation equation. Say if this equation is not satisfied, you should be able to kick somebody out, right? When you go to MPEG-4 and those kind of systems, those become very, very hard. Being able to predict how much bandwidth you need, being able to predict how much memory you need, being able to predict how much CPU you need becomes very hard, right? And I think that, like in terms of research or in terms of where we want to go, that's one big difference. As you had fairly simple compression, like MPEG-1 or what have you, right? You could say that the streams were using 1.5 megabits per second or something, so you can actually predict how much bandwidth you need. You can predict some of these components. But in the newer constructs, that's no longer true, right? And you also are using high definition TV or something, so you have much more variability, right? High definition TV can use like 45 megabits per second or whatever, depending on what the stream is. Yeah.
What's the cost of over-predicting your storage requirements? Like if you say, well, you know, my storage requirements are changing a lot, but if I just take the high end of what my storage requirements will be, what's the cost to the image?
So depending on so one way to solve that is to go with the upper end of predictions, right? So you can assume that if you assume an MPEG-4 for HD to always be all iframes, that's the sort of upper end in terms of network bandwidth, right? So if you do that, then your cost of the system has to go up. The kind of TO I'm talking about, I'm not willing to pay $10,000 for the TO or something. I want to pay as little as possible, right? So you don't actually want to develop a system which is on the higher end of the stuff. Right?
Well, I mean, like, what's the cost of, like, say...
You'll kick somebody out when you don't have to.
Oh, okay.
Right? So if you're building like a TO or something which is like dedicated, then you over provision a system to deal with a stream that may never happen. If you're doing it as a media center or something, you'll kick someone off because in the worst case you won't be able to service them. What you're really looking for is the average case, right? So the whole notion of being able to kick someone off depends on the fact of what I want to look at, the average case or the best case. Back then it used to be the same, but now the average case and the best case can be quite divergent, right? So if I want to do admission control, I gotta choose whether it's the worst case or the best case. And in the worst case, I can kick someone off when I don't have to, or I may keep someone when I can't really service them, right? So either of those that has changed since then, right? So in terms of research, in terms of building systems, MPEG-4 is annoying, right? Because MPEG-4 kind of makes the whole system not so nicely predictable. So especially if you're doing research projects, right? So not being able to predict makes it that you have to actually perform experiments to figure out what's the thing, right? So actually, like your answer makes me think like I want to look at how a typical MPEG-4 encoder behaves for static contents, right? So things of that nature, so things that you expect to be a certain way is no longer true, and stuff of that nature. And we're not even talking about these things. These are, as far as I know, most of the MPEG-4 streams that you can get are not doing object-based coding. They're not using sprites and stuff, right? So once you begin to see those, then things are going to be even wilder, right? So for example, the case of the dome, right? Essentially, you need to send one sprite and that's it, right? So its requirements are pretty, it is not your average MPEG-4 string, right? Whatever the average means. So the other nice thing about the paper is they had some table, right? So this is the stuff that was in the paper, right? They're talking about the cost and the latency and data rate, right? And they look horrible compared to what you can buy right now. So for example, in the hard disk that they talked about, the latency they were talking about was 25 milliseconds. Whereas actually I couldn't figure out what is it for the newer laptops, right? But if you look at the desktop hard drives, it's like 4.1, which is like way lower than that. This is the SCSI, and more importantly, these are for the Zune would likely have one of these too, right? I think it has a 30 gig hard drive, right? 30 gig or something, I think, right? So if you use a 30 gig hard drive, it'll be like this or like this, which is still a lot faster than what we had back then. I don't trust this one because they claim that the 80 gig iPod drive can service 100 megabytes per second. I don't trust it because I think this is a theoretical maximum, and because your $1,000, $2,000 SCSI drives can only do 125, right? So I think it'll be closer to here, right? Yes.
Why is the 4 gig drive so much slower than the 80? Wouldn't it He's faster because
No, it's spinning also slower. The 4 gig is also the 0.85. It's a quarter-sized hard drive. So I don't know how fast it's spinning, but I'll be surprised if it's spinning at 4200 or something, right? I think this is probably spinning at 4200, and this is probably spinning at 2400 or whatever, right? This is the iPod Nano thing. So yeah, so this is not spinning too fast. So, but still, compared to like back then, right? So I think back then a server hard disk was like 1 or 2 gig, right? So the server hard disk that they're talking about is this, the one on your Nano, right? So
Nano solid state.
or the mini.
Okay.
I think. Okay.
Yeah, mini was disk, so this went to nano, that was solid state. And now actually the smaller disk-based one is the iPod. The regular
Okay.
one.
Okay. So, yeah, whatever, right? Maybe Apple never had. They had this, right? First.
Yeah, they had a mini with a hard drive.
Okay.
The mini was like this, and then they did the nano, which was much smaller, but that was solid state.
Okay. So whatever. Yeah. So yeah, the smaller hard drive is. So the disks are getting faster, but actually the disk I don't think became as fast as everything else, right? So when you're talking about MPEG 1, with 1.5 megabits per second or something, it's nowhere close to if you're doing HDTV, right? Your HDTV would be 12 or something. So you're seeing like a 10-fold stuff increase there, whereas depending on what kind of hard drive you use, your hard drive is not fast enough. Your network is not fast enough, right? Actually, I jumped on one of the big issues that I actually mentioned this before, which is the notion of admission control, right? Admission control was a big deal before. It may or may not be a big deal right now, but it's a lot more harder right now because you don't know how much to play with. I actually have some more research that we were working on a little later, which talks about why admission control is still a problem, right? And in terms of the disk layout, right? Back then they still worried about C-scan and stuff. It may or may not be true right now, right? So if some of you didn't have a course project idea, this is one thing to look at. I keep trashing that the whole disks are no longer predictable and stuff, which is the conventional idea. But it may be the case that for practical purposes, it may be good enough, right? So trying to see if a disk is actually being, if you can actually predict whether sectors on the outer end happen to be on the outer end, that may be a good thing, right? The other stuff that people worried about a lot is the buffer management issues, right? In terms of how much, so when you read the contents of the disk, how to manage the memory buffers to send this contents out, right? And I'm not sure if it's still a problem at all, right? Because your iPod device, if I still forget whether it does 30 seconds or so play out, right? It has a fairly large buffer to store its contents. So if you can jump up and down, it's buffered. So once you have enough buffer, right? So what is a reasonable memory for your desktop? Assuming that you're not a poor graduate student, undergraduate student, assume that you get a job, right? And you're out in the real world, right? What would be your notion of a good desktop memory?
a gig and a half, maybe 2.
For desktop?
Thinking about a gig, but
Still 120.
I
I think gig is too small, right? What?
What would you be doing with the gig?
Yeah, I haven't even gotten close to.
Oh, well, so I'm going by what is the typical desktop that you buy, not the cheapo, like not the Dell has like, if you go to the website, they'll have like, $100 for a complete set, right? Ignore that, right? But the reasonable system.
It's like 2 gigs right now.
512
just
to a
bought
gig.
one with 2 gigs.
2 gig, right? That's what I go by, right? So.
The only thing is, I just don't see, like, unless you're really doing a lot of stuff, how you're going to use up over 2
gigs.
So what is reasonable for people to be doing?
I don't know, most people just surf the web, open a couple of Office documents, watch a couple of movies, listen to some music.
So
What about editing movies?
But see, that's
Not that
something
many
that you
people
do
do.
that requires multiple gigabytes, but the average person doesn't edit movies.
So I'm saying I'm not going by what I know, right? I'm just going by what Dell is selling as the reasonable system, right? The reasonable desktop that they're selling,
Well,
right?
Dell's preparing for a Vista to come out, and Vista's requirements are obscene.
So it's a chicken and egg problem, right? No, it's a chicken and egg problem, right? I'm saying if Dell believes that the average user would have, let's say, 1 gig, right? Or not the cheapo user, but the normal user, if Dell thinks it's like 1 gig, right? Then Microsoft has to use that 1 gig. I mean, it doesn't make sense for Microsoft or whatever software manufacturers to be really stringent and use only like 1 meg or something, right? Because it's there, right? So it kind of feeds off of each other, right? So without us making any judgments, right? I mean, it seems like 1 gig is a reasonable desktop memory that you can get, right? So if you're going to run, and I would think that if you're running a media center or something, 2 gig is not unheard of, right? To media center to record movies and stuff like that, right? So if you have that much memory, then managing buffer, how important is it? I mean, how important is it to figure out which pages to keep, which pages not to keep, right? So yes, you can use the 2 gig for actually doing useful stuff, whatever that useful stuff is, right? Or the 2 gig can be used for buffers and stuff for the OS, right? So if you don't believe that 2 gig can be useful for applications, then that's even great. So you have 2 gigs to play with at the system level, right? For buffers and stuff like that, right?
I don't know, it just seems like, computers get better, technology gets better, but my internet browsing has been the same since, my connection was 28K, because they keep adding more stuff.
Yes. So it's kind of hard, right? So like if you run, like if you go to YouTube, right? You suddenly like you're downloading your Flash plugin, and your browser is no longer the simple small one, right? No, it's consuming a lot of memory, and it changes the whole thing, right? So I'm not really convinced that memory is such a bottleneck anymore, because memory is so cheap that you ought to be able to get more memory, right? I don't think research should be focused on getting the buffers, worrying about the memories and stuff, right? When iPod can have 30 minutes worth of buffer, I think the game is over, right? Because iPod kind of devices ought to be worried about cost a lot, right?
So it reads the disc once every half hour?
Yeah, once every song, I think. It reads and then keeps the whole thing, right? If you have iPod, you can actually feel the disc moving, right? And it rarely moves, unless you're like shuffling songs, in which case it's very slow. I mean, it's painfully useless, right? I mean, if you want to suddenly jump, if you keep forwarding through songs, you hear the disc go slowly. I don't know, people who have iPod,
See, yeah, I don't know, whoever wants to try it, I can lend their.
Is that a hard disk or?
Yeah, hard disk based.
How big a hard disk is that?
30.
Okay.
I just got the one 3 months ago.
Okay.
But basically, if you look for a song that's nowhere near to be found, it'll take about 2 seconds to find it, and you can hear the whole thing just moving, trying to find the song. But once you get it, it won't stop whatsoever. I think those are solid state though.
That's solid state?
That's solid state.
Okay. Yeah, so that won't have the problem. But the other, so it has the whole thing buffered. So essentially, the way I notice it, once you start playing a song, the disc goes for a little bit and then it kind of goes off, right? Because it's just playing out of the memory, right? So if they can do that, then you ought to be able to do that for your desktop, right? I mean, it's so the USB key, 4 gig is $65 or something, right? 4 gig USB keys.
No, 1 gig USB key is 65 right now, unless the price has suddenly changed.
No, I saw Newegg, it's on sale for 65 or something, right?
65, 4 gigs?
Yeah. It's a no-name brand, but like, who cares,
Who
right?
cares? Yeah, no, I bought a gig like a year ago and it was 65.
Yeah, I know, but I'm saying like, it all seems so cheap, right?
Oh yeah.
So the other stuff that the paper talks about is the notion of striping, right? How do you organize the disk? How do you stripe the contents, right? I think that's still valid. In terms of if you have multiple disks, being able to stripe across the different disks and either bitwise or blockwise, right? Using some sort of a RAID scheme, that's still valid, especially for DVR kind of devices. Even though most DVRs that you can get only has one hard disk, right? That's one of the pet peeves about the way computing is going, that desktops don't really come with mirror disk, right? And laptops don't really come with mirror disk, and they ought to, right? But no one seems to want that, right? How many of you had like people who are using laptops, right? I seem to have my hard disk crash every year or two, right?
That's what you do with it. Mine has crashed once in 3 years.
My desktop, the laptop is everything, right? So it's on all the time, right? It barely sleeps except when I'm going from point A to point B. Isn't that what like you would do? The people who use laptops all the time, right?
I turn this one off and only use it occasionally.
Okay, so you have another.
I have a desktop back in the room.
Okay.
That's the one that commonly goes above 40 days on straight.
Okay. But for the others, people who are having laptops, right? Is that your primary thing, or you go after something else? So if that's your primary thing, right? Then if you look at the hard disk specification, right? It's not supposed to be on all the time. These hard drives are not supposed to be on all the time, because they make compromises on the heat stuff, right? I don't know how to. I can't have two laptops all the time, right? So
You just get a ghost. Well, if you want to back up your data.
Oh, I know. But I'm saying like somebody ought to put two hard drives into this thing, right? Rather than me forcing me to back up all the time. I'm saying
Some
being
people just started doing that.
What?
Because some like Alienware started doing that.
I know. I'm saying it can't be such a rare thing, right? That's such a common thing. But at least on a desktop, right? Like I think this I asked in the OS class, right? How many of you have a desktop which is rated or whatever, right?
Yeah, the only problem with RAID is if they're made from, the discs are made from the same manufacturer on the same line on the same day. It's like, well, they might fail at the same time.
Oh, but statistically, let's assume, let's assume.
You're an optimist.
No, let's assume it's a random failure model, right? But forget about it. Even if it's not random, buy from different manufacturers, right? But I'm saying like desktops ought to have more than one hard disk. The hard disks are so cheap and they're
But then
so.
you have to say to the consumers, hey, your hard disk might fail. That's why we threw a second one in there. And so people say, oh, it's not really.
Whatever, right? So if you do have that, then I think being able to stripe these contents, right, is still a valid option. The paper talks about the notion of a period. Meaning how often things have to be played again. So if you're talking a video on demand server, then being able to come back to the same content kind of defines how many times you have to go through the hard disk, and that kind of defines what you can do. And the issue of if you have multiple media clips or single media clips, right? And the next slide I'll say a little bit more about what it means for something else that we are doing right here, right? And one of the things that they used to do is like delay when the movie starts, so you can do this play out with buffers and stuff. And I just don't think that memory is such a big deal right now that you have to worry about some of these constructs. Since the memory is big, you can, like what you do with iPod, read a whole bunch of stuff and then play out from the memory, right? So at this point, I want to kind of like throw into like a more of a research kind of challenge, right? One of the things that I think I talked to some of you is we did tape these lectures, and we want to make them available to everybody, right? So suppose we build a storage, like a media storage, where you store all these contents, and people can get contents off of the storage, right? So we have this black box, which is a storage, and it has a network, right? So what is a reasonable storage size that you would want in such a system? Suppose you kind of put this around, and cost is the biggest factor, right? You can do this from your home. In your home, you can have the storage that you kind of store contents off of it, or what have you. What would be the storage that you would want to build into this stuff, into this hypothetical storage?
Doing video.
Hmm?
We're doing video.
Anything. Let's. One of the applications you can do is like store the lecture videos and stuff, but we are talking about storing anything, right?
Well, I would say, how many users do you have, first of all?
Let's not get there. Like first, let's see. Right now, I'm trying to optimize the cost, right? What? Huh?
JBot.
What?
Like a JBot.
Yeah. So how much? What size would you think is?
Half a terabyte.
Huh?
Half a terabyte.
So in terms of the cost, right? 320 gigabyte is the cheapest. Gigabyte per dollar wise is cheapest, right? I think this retail, if it's not on sale, I think it's like 0.33, 33 cents per gigabyte, right? And 750 gigabyte is more expensive. It's more like 0.5. So it's 50 cents to gigabyte. This is 33 cents to gigabyte, right? So if you buy a 40 gig hard drive, I think it's like 65. And if you buy a 320, it's like 69, right? So you don't want to buy 40 gigs. So you would want, so I think you would either choose this or this, right? So you would choose this because there's a cost, amortization cost, right? Because you can't just put the hard disk. You have to put it into an enclosure. You have to pay for the enclosure. You have to pay for the, the hard disk has to go in somewhere. So there's a fixed cost for this stuff. There's a fixed cost for, there has to be some kind of a CPU in here which is attaching to all this stuff, right? So if you want to reduce that cost, you would want to, let's say, put one of this stuff, right? And you would want to put many of these hard drives in. Like, so if people are build these PCs and stuff, you would want to put 4 hard drives because that's the number of ID channels you have on a typical motherboard, right? So let's assume that we go with this one, and let's assume we go with 4 of these, right, to bring the cost of these devices down, right? So how much is that? 1320, right? How much is 4 of?
1280.
Okay. You go with 1280 gigabytes, right? What kind of network would you have? It can either be wireless, right, 802.11g or something, which is 54 megabits per second, right? It can either be 100 megabits per second. That can be. It's one of these options, right? I mean, what? Let's leave it as the 3 different options. Yeah, I mean, depending on where you are. If you're at home, you probably go with gigabits per second. I think Notre is rewiring itself to go to gigabits per second at some point, right? So you can build one of these devices with gigabits per second and certain hard disk. So I think you can build it for like $400 or something. This 1280. You can build a whole bunch of these things, right? For storing contents, right? Let's assume that you're storing contents for anybody can store contents into this one, right? So, which means that if you want some storage, since it's only $400, Notre decides to do this for all the students and puts the storage here where you can all store contents, retrieve contents, right? So if you do that, that defines what the access rate is, right? So you can use that to define whether you expect the disk, all the contents to be used equally likely, or whether some items are going to be popular, right? Let's assume that all the contents are going to be equally likely to be used, right? I'm actually setting up to go to this graph.
Oh, are you going to go to the OIT town hall meeting?
No. No.
Running time on you. So I was thinking you could go there and yell.
No, I mean it's so like. I mean it's not. I don't know. I just given up on them. Right? No, I kind of given up on them because it seems like there's a big disconnect between what they say and what I know, right? So anyway, so this graph is a very crude graph. It's not anything scientific. I mean, you basically do the calculations, assuming that you have different size of storage, right, on the x-axis, and the y-axis shows the number of times that the storage can be serviced for different networks. So, for example, this is a gigabits per second Ethernet, right? So this is a simple graph because this is not actually measured from a system, right? So this assumes that the gigabits per second card will give you gigabits per second throughput, right? Real systems has issues that you don't get that much capacity, right? But let's assume that. So, and for example, for the 54 megabits per second, we assume 54 megabits per second. So this is the upper bound, right? It's not possible for you to go beyond that. So this is the theoretical upper bound. So this tells you how many times you can service this contents in a single day. That's the paper calls it the period, right? So if you assume that all contents are equally likely to be serviced, that's the amount of time it can be serviced in a whole day, right? So this graph only goes up to 750, right? It doesn't go to the 1280 that we had up there, right? So it's also possible to the biggest you can do right now is 750. That'll be 3 terabyte, right? So if you do 3 terabyte, the graph will be somewhere up here. Essentially, this says that if you have, let's say, 100 megabits per second, right? I don't know what this number is, like let's say 1 or 2, right? On average, you can only service once or twice a day each byte, because the network would be the bottleneck. Does that make sense? Right? Gigabits per second would give you more stuff, but so when you're designing this system, right? I think the bottleneck is no longer the storage, because in fact it's cheaper to add more storage in here, but you can't get the stuff out of here, right? So think of this as your DVR stuff at home, right? So your DVR, you don't want to attach a storage to a DVR. You want to have this one storage at home, which will be used by the DVR, used by something else in your home, right? So then you have to figure out what goes into this storage, what goes into this network within your home, right? Yes?
But I mean, doesn't this really just depend? I mean, let's say your example, right? I want to put all my movies onto one central server, right? We know there's never going to be more than one person, me. So the network isn't necessarily an issue. Assuming the network can stream one movie at a time to me wherever I am.
Yeah, so
I mean, I may care more
if you're
storage.
If you're only one user, right? Then yeah, this 100 megabytes should be fine.
All right, and I'm just saying at that point, doesn't the storage potentially become an issue? I mean, what if I have 1,000 movies that are 10 gigs apiece?
But if it doesn't matter how many. So this graph only doesn't show how many movies there are, right? It says like if you fill up the whole storage with so if you fill up 750 gigabytes with movies, and you watch them all from once, right, in a day. You can't watch them all in a day. Let's assume
the number of movies plays into the available storage space, right? I mean, if I want to have more movies, I need more storage space.
Yes, but I'm saying the graph really concerns how many of them can be serviced.
Right. Right.
If you
but you were just saying that the amount of space on the server isn't really an issue, and I'm just saying, well, it depends on your application.
Well, I'm saying it's easy to add space.
Right.
Right? But if you add space, you're only getting this graph. So if you add space and you're filling it up, so it's harder to explain for one user, right? Because you're only watching it once, right? So I'm saying if you put the storage here for all of us, right? And I can easily do 3 terabytes, but the 3 terabytes, you cannot get into it because the network is not fast enough. I think if you do 3 terabytes, you can't even have a gigabit. I think you need to have more than a gigabyte, right? Gigabits per second for you to get to it, right? So the admission control in this setup is kind of a weird thing, right? The hard disks are getting bigger and bigger. Network is not getting any bigger, right? Admission control, I'm talking about playing one movie a day, which sounds so little, right? But since the storage is getting bigger and bigger, the amount of data that can be streamed through the stuff becomes a challenge, right?
So how do you fix that?
Well, that's what we're working on for research.
Update everybody to a gigabyte?
Oh, but that won't solve. So that's the thing, right? Yes, you can solve it right now by updating to gigabits per second, right? But the storage is getting bigger faster, right? Especially in like Notre Dame product took like forever to upgrade to gigabits per second, right? But I can fill this up fairly quickly, right? Yes.
How does this graph relate to how many users can be looking at a movie at any time? Is that totally unrelated? No. So that's what I'm saying. If you assume that each object are likely to be used by different users, no. If one user is playing through this whole thing, then this won't be an issue, right? If you have lots of content, then you're likely that somebody would be interested in some content. The more content you can store into one area, the network becomes a bottleneck.
Why don't you just force them, like if somebody reads something off your server and they still have it in their computer later on, why don't you just force them to send it out to somebody else who
the ways you can solve them, right? So one simple way is to have like this much space, but not make it available, or not advertise it, not let you store, not let you use the stuff, right? That'll solve the problem too, right? I'm saying we never had to worry about this problem before because the paper, which is not that far back, was talking about 1 gigabyte or so of content, right? 3 terabytes was not considered to be something that you can have in your desktop that far back, right? I mean, terabyte was still supposed to be some big number, right? So, right? But terabyte is not such a big number, right? So when you have 3 terabytes sitting in your disk, you run into a totally different problem than what this paper is talking about, right? My point is, the paper was talking about some issues because the network was like, they probably had 10 megabits per second or 100 megabits per, 97, we had 100 megabits per second, fairly common, right? So they had the same amount of network, so they were worried about how to service these stuff and a server kind of thing. The kind of application I'm talking about is not a server. I mean, you're thinking of a storage which is not that big a deal, right? It's cheap. It's not a server. I can stack up the storage easily, but your network is the bottleneck, and the admission control is based on a much looser construct of what the storage is and stuff like So some other things keep changing, right? So yes, it's very likely that these machines can have lots of storage. In fact, I think 2 or 3 gigabytes, 2 gigabytes is a given, right? I think a gigabyte of desktop memory is like what, $34 or $40, right? So there's no reason why you would have less than a couple of gigabytes, right? Because it's so cheap. But the network is the bottleneck in a weird sort of thing, right? So anyway, so that's what I want you to think about when you read the paper. The paper seems very outdated, even though it's not. I mean, it's less than 10 years old, but it seems so outdated because they were talking about a few gigabytes and what have you, right? But in the newer context, what they call as servers is essentially what we're talking about. So in the case of my home, right, what they would call as a server is the TiVo thing sitting on top of the TV, which can deal with 3 different streams, in and out kind of thing, right? So in terms of the zone, right, I don't like too much about zone, but I'm not sure how zone reacts if you actually, I don't know if you can do that. I actually don't. I mean, we can't buy it, but I don't know if we can actually service 3 different users while still playing, right?
Well, you could partition RAM into 4 segments, and then say, okay, when I'm sharing songs with other people, dump the song, a copy in each of the 4 segments, and then play off one copy and then transmit the others.
I'm saying you could. I mean, yes, you can think of solving it, right? Oh, but I'm saying anybody who buys a Zune, right? If they say you can share with 3 users, this is what you expect, right? And we know how to solve them. I mean, it's not a big deal. But I'm saying, but no one thinks of Zune as a media server. I mean, you think of that as this cheap little thing, right? I mean, you think of this as a personal device kind of thing. You don't think of this as like you don't look at the papers which are published 10 years back on how to do media servers to implement disk scheduling on a Zune, right? Which is what essentially boils down to, right? Mostly because the Zune is not, I mean, it's going to use the 1.8-inch hard drive or something, which is not that fast, and it's trying to do this stuff, right? So I actually want to see how Zune is for these kind of things, right? I also think that Zune will probably fail because of their really horrendous DRM, right? So for example, you can share contents with 3 users, which I think they can play for 3 times in 3 days, right? But they can't share it further, right? Which I have no idea what that's about, right? So I can give you the song, you can listen to it, but in 3 days, it becomes useless for you, but you can't give it to anybody else. So,
then you could just sit there with 2.
What?
You could just sit there with 2, pass the song back and forth.
Yeah. Who listens to one song that many times?
But anyway, but right now it's useless, right? You know. So that's all I have for today. So we'll look at the HP media server on Thursday, right? So read the paper and at least get the sense of what the intro and motivation and all to see where the paper is going. And if you need to talk to me about the projects, drop by.
Is that a project idea okay?
You what?
Project idea okay?
Sounds fine.
All right.
All right, Deborah.